Assalamu alaikum wa rahmatullah. This is Bassam Hussam and my metric number is 195569. And today we will be presenting our experiment, which is measuring angle and roundness, me and my group mates. So I will be conducting the objectives and the introduction for now. So let's get started. As for the objectives of this experiment is to perform the eccentricity measurement using the test indicator. So the eccentricity is a measure of how much a conic section varies from being or resembling a circle by definition. A conic section is a curve which is obtained from the intersection of the surface of the right circular cone with the plane. Eccentricity is specifically a parameter of many conic sections, and conic sections are fundamentally similar if and only if their eccentricities are the same or equal. The eccentricity of a circle is 0, and for a parabola it is 1. However, the eccentricity of an ellipse is the ratio of the distance c between the center of the ellipse and each focuses to the length of the axis A. So I'll be passing it to my friend to continue.
So for the apparatus that used for the experiment, this include the ROG221 SS model of runout gauge system. The secondly is the vernier caliper, and the last one is the cylindrical workpiece. So as you can see here on the figure 4.1a, B and C. So this is the apparatus with its setup for runout gauge system. So for the 4.1a, we use two cylindrical workpiece, which consists of the big cylinder and as well as the small cylinder. So for the second picture is the ROG221 SS model of runout gauge system, and the last one is the uh, the measurement meter that we use to capture the roundness of the cylinder. So for the next part, I will pass to Muhammad Adri.
Okay, so for the procedure of this experiment, the first one we need to start with place the workpiece on the retainer holder and two types of rollers are selected. And then after that, the work retainer front was brought onto the front end of the workpiece after carefully rotating the front retainer to open place and angle screws. Then both of the screws were tightened. Next, the work retainer, which is the rear, was brought on to the back end of the workpiece after the rear retainer was carefully rotated to open the position screw. Okay, then the screw also tightened, and the next step is a contact probe of the measuring device was attached to the right angle of the workpiece and surface to begin the measurement on it. And for different type of rollers, we just repeat the step 2 to 3. Okay, thank you.
So for the result, we measure the roundness for the two cylinder workpiece with respect to its maximum and minimum value. We take note for the reading of the roundness for each cylinder, which taken at three different point location, which is point A, B, and C, which is the front, back, and the middle. So for the big, for one of the cylinder, we measure three different value, and it consists of maximum and minimum. So for the next for the next part, I will pass to the next presenter.
Thank you, Kim. So I will present the discussion. So as for me, discussion. So we have two type of cylinder which is big and small. So the maximum reading for the big cylinder, which is at point A, is the 0.49 and the minimum is 0.2. And the second point, which is point B, we get 0.44 and the minimum is 0.0. So at point C, the maximum reading for the big cylinder is the 0.23 and the minimum is negative 0.01. So followed by the small cylinder, The maximum we get 0.00 and minimum 0.00 for the point A. So for the point B, the maximum is 0.01, the minimum is negative 0.04. And for the point C, the maximum is 0.15 and the minimum is negative 0.12 millimeter. So the maximum and minimum roundness was calculated by taking the average of the values. So from the result we obtained from the calculation, the overall experiment reading was satisfactory, and I think it will acceptable. So however, there are a few source of error in this experiment, which is the improper calibration of instrument. So also, since the material is clamped, lobes can be formed when removing or turning the material, which can affect the roundness measurement. So I think that's all from me. I will pass to the next presenter.
Thank you, Najmi. So, in conclusion, the experiment was conducted successfully by following the procedure as Hadri explained just now. And we observed that the more the center of gravity and center of rigid differ, the higher the eccentric ratio is. So, with the general bench centers, shaft bend and circular pitch run out of gears and can be measured. So, basically, this is the reference throughout our experiment. Thank you.
Okay, as for experiment 2, which is the angular angular measurement by using the sine bar method. First of all, the objective experiment, which is to understand the sine bar and the angle gauge block for the angularity inspection. Second of all, indicate the height of the gauge block stock h and the size of the described angle theta. Okay, so let's move on to the introduction. An adjustable protector is gradient round protector with a pivoting arm that is used to measure or label the angles. Variance scales are often used to provide more accuracy measurements. It has a wide range of applications in architectural and mechanical drawing, but with the availability of margin drawing software or CAD, it is becoming less common in that field. In metalworking, a sine bar is instrument used to calculate angles. It is made up of hardened precision grounded body with two precision ground cylinders attached to the ends. The width between the cylinder centers is precisely regulated, and the top of the bar is parallel to the middle of the two rollers. As in usage, the dimension between the sliding surface is chosen to be a multitude and creates the hypotenuse of triangle. So I'll move on for the apparatus experiment set up to my roommates.
So for the apparatus that we use for this experiment, including the sine bar, the second one is the angle gauge block, the third one is the linear gauge block, and the die gauge, and the next is the surface plate, and the last one is the vernier caliper. So as you can see on the figure 4.1a, this is the die gauge, and the 4.1b is the linear gauge blocks, and 4.1c is the sine bar and the angle gauge block. So for the procedure, I will pass to the next presenter.
Okay, thank you, Hakim. Okay, so for the procedure for the experiment, so the first step is we need to measure the gauge block, which is X, Y, and Z, using a vernier caliper. We assume that the alpha 1 and alpha 2 will be 90 degree. Okay, then the sine bar and the components were set up as shown in the video later. We will show it. And the next step is we need to set up the angle for measurement. The gauge block stack was positioned under the stack end of the sine bar. And then to ensure that the dial gauge was parallel to the surface plate, it was slid along the surface of the angle gauge block, and the dial gauge reading remained unchanged while angle gauge block was in the flat location. Okay, next. Okay, so for the next step is New combination of linear gauge block were used before the angle gauge blocks flatness and parallelism were perfected. And the last step is the experiment was carried out 8 times with 8 different linear gauge block combinations. Okay, so for the result, I pass to minus
So,
Akim.
okay, thank you, Hadri. So for the result, we measure the angle gauge block with its component first, which is x for its height, y for its length, and z for its width. So the component for x is 30.15 millimeter, y is 75.20 millimeter, and z is the 12.66 millimeter. So from this measurement, we can calculate the theoretical angle theta, which is 13.09 degree, and the theoretical height, which is 22.65 millimeter. So for the experimental result, we conduct the combination of linear gauge blocks with respect to height and flatness for this experiment. So this is the result that we obtain when combined of linear gauge block. So from this combination, we get the average 22.60 millimeter. So for the discussion, I will pass to the next presenter.
So thank you, Akim. I will proceed to the discussion. So as for discussion, the theoretical height that we get is the 22.65 millimeter, and the theoretical angle is 13.09. So based on the table 6.2, the first combination of gauge block is too low for obtaining the flat position. So the total combination is the first one is 23 millimeter with a linear block of also 23 millimeter. So in addition, we get it has the highest gauge reading, which is positive 23. So after a few trial and error, the combination that has achieved constant gauge reading is 22.60 millimeter. So this final combination has two number of block, which are 21.5 millimeter and 1.17 millimeter. So experimental height value is slightly different compared to the theoretical value. So the percentage error that have been calculated is 0.31%. So from the percentage error, 0.31 considered as a successful experiment as it has a low percentage error. But there are many factors error that affect our experiment of the error. So the first error is the tools that we have used. So there are some rust particles which affect the smoothness of the contact surface between sign bar and angle block. By having a slight deformation in tools, it will result in surface of the angle block and the roller axes are not parallel to each other. So another error is the progressive angle error. So this error occurs when there is a slight difference in distance of the rollers. So and to improper setup of the experiment can result in this error. So therefore, several precautions we need to be considered during this experiment. So I think that's all from me. I will pass up to the next presenter.
Thank you, Nazmi. So we're going to look for the conclusion. In conclusion, the experiment was conducted successfully, and we found out that the measurement apparatus like SIN bars and gauge blocks are usually manufactured to high tolerance to ensure maximum accuracy. So here are the reference we attached throughout the experiment. Thank you.